So today we're going to learn about the derivative of y equals ln x. Well, ln x is just the natural logarithm log base e of x. So I can rewrite this as e to the power of y equals to x. Well, I want to take the derivative of both sides, but I don't know how to do it with y. But I know that if I take the derivative, I need to write dy by dx, and then I can say that I want to do the derivative of e to the y, and the derivative of x is 1. Solving for dy by dx, I get dy by dx is equal to 1 over e to the y. I know that e to the y, though, is equal to x, as I stated up here. So I can rewrite this as dy by dx is equal to 1 over x. So this shows the derivative of ln x is 1 over x. And I can write f prime of x is 1 over x. So let's look at some examples. I want to differentiate ln 3x. So I'm going to say that gx is equal to ln x. And I'm going to say that h of x is equal to 3x. So inside and outside. I'm going to say that g prime of x is equal to 1 over x, because that's the derivative of ln x. And I want to say that h prime of x is equal to 3. So I know that y prime is equal to h prime times g prime h of x. Well, this simplifies nicely to 1 over x. Let's try another one. So I want to do ln of 6x minus 4. So I can say that g of x is ln x. I can say that h of x is the inside 6x minus 4. G prime of x is 1 over x, and h prime of x is 6. Putting these together, dy by dx, I get h prime times g prime of h of x. Well, let's put these together and factor. So I'm going to do 6 over, and then I'm going to factor out a 2. So I'm going to get a 2 here, which leaves me with 3x minus 2 in the bracket. Now I can simplify. This 2 is a 1, and this 6 becomes a 3. So this leaves me with 3 over 3x minus 2 as the derivative. Let's look at this one here with a nice long polynomial. So I want to say that g of x is equal to ln x. And I'm going to say that h of x is equal to the nice long polynomial 5x cubed minus 2x squared plus 7x plus 10. I know that the derivative of g of x, g prime of x, is 1 over x. I can then take the derivative of h prime of x, or of h of x, which is h prime. So 15x squared minus 4x plus 7. So dy by dx is equal to h prime, which is 15x squared minus 4x plus 7, and I'm going to multiply that by g prime of h of x. Well, let's put that all together, and we're left with 15x squared minus 4x plus 7 all over 5x cubed minus 2x squared plus 7x plus 10. Okay, looking at one more example, and then we'll look at the pattern. So if I take g of x to be ln x, I can say that h of x is equal to the cubed root of x to the 5. Well, g prime of x I know is 1 over x. And h prime of x is equal to 5 over 3 x to the 2/3. Well, where did that come from? Well, an easy thing to do is rewrite this as x to the 5 over 3 instead. Putting this together, we get dy by dx is equal to h prime times g prime h of x. Well, let's simplify this a little more. We're going to get 5x to the 2/3 on top. And on the bottom, we'll get 3x to the 5/3. If I simplify that, I get 5 over 3x. Ta-da! Now we can pull together and come up with a formula or a shortcut that might help us. So if we look at the pattern, what seems to be happening is if we have the function f of x equals to ln some function a of x, the shortcut is f prime of x equals to a prime of x, so the derivative of this, all over a of x. And we can use that when we look at the second page. I'm going to do the second page in a part 2 so that we don't run out of time. So to watch part 2, please click on the next link.